Hello, it's Mrs. Vore here to give you feedback on lesson 5.1. So lesson 5.1, we covered histograms, stem plots, and that's it, histogram and stem plots. So before you finish this video, you should make sure that you have your 5.1 with you. So I need to, for most of you, I need to email it to you. It's graded for everybody, but I need to scan it in and send you a PDF of your submission so that you can at least compare what you turned in to the feedback that I'm giving you. If you want to print it out and make corrections on that, great. If you just maybe want to take notes on a piece of scratch paper, that might be a good idea. But I would make sure that you wait to go over this feedback until you actually have your assignment to compare to it. I think you'll get the most out of it in that case. If you haven't turned it in yet, then I would still get it out and I would compare my answers to your answers. On all of these feedback videos, I'm going to try to keep them as short as I can, not because I don't want to give you thorough information, but because it will become cumbersome for you guys by the time you get to 5.5. So I'm not going to go into as much detail maybe as some of you guys need. So just know that any lingering questions that you have, you can email me, you can come in and see me, you can wait until next week till we see each other to ask any questions that you might have. Okay, so number 1 went pretty well because I started this for you in class. So this is the gas mileage stem plot. Almost everybody had the key and the stem plot was set up correctly. What a lot of people got wrong is use your calculator to construct a histogram of the same data. And the question is, do you get the same graph? And for most of you, the answer should be no. Like for 90% of you, the answer should be no. In fact, if you said yes, I'm curious to know why your calculator would break it down like we did in the stem plot. And here's why. Because on a histogram, and this is feedback in general that everybody needs, when you're choosing the scale for your histogram, in our brains, we don't necessarily think, okay, I'm going to start my bin at 31.8 and then I'm going to use a scale of 1 and end at 42.1. That's not how our brains work. How our brains work is we see, okay, the lowest number is 31.8, so I'm going to make my lower bound 31 and I'm going to make my upper bound 43. So it is unusual for me to see you guys setting your lower bound and upper bound to the actual minimum value in the data set and the maximum value in the data set. So lots of you guys said on this one, I'm going to make my minimum 31.8. That seems weird to me because if you then use a scale of 1, your max would have to be 41.8, not 41, not 40, oh, sorry, I'm looking at the wrong number. If you start your, so some of you guys wrote, my X minimum is 31.8 and my scale is 1. If that's the case, then your max has to be 42.8. Because you have to go by your bin size. So one of your bin would be 31.8 to 32.8, then 33.8, then 34.8. So if this is not making sense to you, what I'm saying here, you might want to get that cleared up. If we're really going to make this histogram look like our stem plot, then we're using our stems as our guide for our X minimum and our X max. Our X minimum is 31. Our X max is 42, but now I'm actually thinking that it needs to be 43. Because 42.1 No, it can be 42 because 42 is included and goes up to 42.999. No, so that's right. And then your scale is 1. So to make your histogram look the same as this stem plot, your x min is 31, your x max is 42, and then you increase by 1 each time. So biggest feedback on this problem, and you'll see it again on problems on the next few pages, your x min and your x max, you usually go to like the lowest whole number and then use bin size 5 or 1 or 10. So, like I said, you'll see this again. On any histogram, it really is helpful if you give your window. Like for your grader, it's extremely helpful to know, okay, they've set their x min to 0, their x max to 90, and they're choosing an x scale of 10. So in this case, I would choose an x scale of 5 or 10. I typically choose an x scale of 1, 5, or 10. And now this goes back to what would it make sense to make your minimum and your maximum. So for instance, you wouldn't necessarily want to make your minimum 28,000 and then go by tens, because then your scale down here looks like 28, 38, 48, 58, 68, 78, 98. And that's just weird. It's like bad math grammar. So if you did a different window on this, I would just make sure you understand what I'm saying when, in the very least, your x max should be 20 and your x min should be 20, your x max I would make 80. It's okay that I went down to 0, but an alternative would be 20 and 80 still going by 10. It doesn't make sense for you to say my minimum is 28,000 and my maximum is 78,000. That's just kind of weird. Make sure that your axes are labeled. This would be better if I wrote number of employees. If you can add context, it's always better to add as much context as possible. So this would be better as number of employees. So if I was grading my paper, I would write better, and then I would change it to number of employees, because that just shows I know the context of this problem. I know that when I say frequency, this really means one employee made between $20,000 and $30,000. 69 is alpha. 74 is beta. I want to come back to 3 last, so I'm going to skip that one. On your student to teacher ratio, you need to split your stems for full credit. If you did not split your stems, that's fine, but your stem plot ends up being really long, so splitting the stems gives you a better picture of the data. The key pieces of feedback on this are, 1, make sure that you have a key and that you are giving your key context. So instead of just saying 16, it's better if you say 16 context, students per teacher. The other big takeaway from this is it is extremely important that you guys understand what this problem is really describing to you, because this is very similar to an actual AP problem. So is this. I wrote at the top. This is the most like an AP question. Unfortunately, you don't get straightforward questions like number 2. You get questions like number 4 that are not only asking you to do something a little bit more challenging, but they're giving you information that you really have to try hard to wrap your mind around. So what they're telling you is they're comparing 2 sets of schools, and they are breaking them into 2 groups. So the first group, or the first set, is the schools that had the highest proportion of students meeting the reading standard, and the other group is the 10 schools with the lowest proportion of students passing the reading test or the reading standards. So the 10 highest scoring schools, the 10 lowest, I shouldn't say highest scoring, the 10 schools with the highest percent of kids passing the reading test, and the 10 schools with the lowest percent of schools passing, or the lowest percent of students passing the reading test. So each one of these numbers is a school. So right here, this is a school that has 12 students per teacher. This is a school that has 7 students per teacher. This is a school that has 20 students per teacher. So it's important that you understand the context of the problem. So 3 things on this guy. Split your stems, give your key context, make sure that you really understand what this problem is about. Number 5 and 6 are another opportunity for you to check your scaling. Almost everybody's histograms were right, but your scales were weird. So in this case, it would not make sense to me for you guys to set your X min to 12 and your X max to 51. Why would you start it at 12? So to me, it makes more sense that you would go from 10 to 50, or 10 to 60, or in this case, 0 to 60. I'm choosing nice whole numbers and a nice X scale on my bin, and I included it. So for me, I did 0 to 60. What probably makes the most sense is 10 to 50, because your lowest number is 12 and your highest number is 51. Remember, this bin means 50 to 59. This bin means 50 to 59. So, I forgot what I was saying. But, always best if you include your scale or your window. Make sure that your X min, X max, and scale make sense. Make sure that your axes are labeled. So lines cleared, number of students. To me, it does not make sense to say my bins are 12 to 17, 17 to 22, 22 to 27. That's weird. Bottom one is the winning margin of the Super Bowl games. I chose a X min of 0, and that is the one that probably makes the most sense, an X max of 55, an X scale of 5. I included it with my histogram, and I labeled my axes. So, biggest takeaways from the histograms. Label your axes. It's always best to include your window. I don't mark you wrong if you don't. It just makes it a whole lot easier to grade. And try to adjust your scale so that it's not going from 4 to 52. You want to go from 0 to 50 or 0 to 55. Number 7, the Barry Bonds set. The dot plot on this is very cumbersome and not helpful. When you make a dot plot that ranges, or that covers, I shouldn't say ranges, never say ranges. When you make a dot plot that varies so much from 16 to 70 something, 73, a dot plot's not going to make sense. You're not going to be able to see the shape as well. But if you change it to a stem plot, all of a sudden you can see the shape much better. This is, most of your data is on the left, and then you have this guy out here, which is probably an outlier. So, yeah, the stem plot looks a lot better than the dot plot. Make sure that you label your stem plot. Just because it's a stem plot doesn't mean that you don't label it. Make sure that your key, that you have a key and it has context. So instead of just saying this equals 37, label it with what 37 represents. It represents 37 home runs. And then lastly, on this problem, when you do a dot plot, you need to include all of the numbers on the scale. So some of you guys only put on the scale the numbers that you were plotting. That's lazy. In the very least, do your tick marks, do your 0, 5, or however many you went, 0, 10, 20, 30. But you cannot just label 16, 25, 24. That's no good. No good. So, must show all the numbers. Make sure you label your stem plot. Include a key with context. So then the last problem I left off because we talked about him in class. I did not write out the answer, but I talked to you about what the positive and negative difference meant. This you truly need to understand because it's about the practice of getting your brain to really think through these complicated problems. So explain what a positive difference indicates. This means that the tree without ladybugs had more damaged fruit than the tree with ladybugs. Lots of you guys were saying things like there was less damage or more damage. You don't want to say that because what you're saying in that context is this tree was less damaged. Well, less damaged than what? You don't have anything to compare that tree to. What you're doing is you're taking two trees and you're subtracting the number of different fruits, the number of damaged fruits on the tree. So I guess in that context, it makes sense to me that you're saying for these trees, the trees without ladybugs, the tree without ladybugs was more damaged than the tree with ladybugs, but it's sometimes the way you guys write it, it doesn't come across that way. So, a positive difference indicates the tree without ladybugs had more damaged fruit. A negative difference indicates the tree with ladybugs had more damaged fruit. And then based on the stem plot, should ladybugs be used? You need to give evidence to back up your conclusion. So you cannot just say yes or no. You cannot say yes because the ladybugs with the trees with ladybugs were less damaged. You have to actually give evidence. So I went in and I found out the percent of pears that had more damage with ladybugs. So 36% of the pears had more damage on the tree with ladybugs. 58% had less damage without the ladybugs. So this means, I think that's wrong. I think this is less damage with the ladybugs. So the trees with ladybugs had less damage. That was 58%. And then 6%, there was no difference. These two observations here, no difference. So I wrote yes because 58% of the pears had less damage when the ladybugs were used. So I guess my wording there is also kind of unclear. 58% of the pears had fewer damaged fruit on the tree with ladybugs. So that's what I would change it to. Yes, because 58% of the pears had fewer damaged fruit on the tree with ladybugs. So feedback for this problem is not necessarily about stem plots and histograms and displaying the data. It's more about, do you know how to read the graph? Can you wrap your mind around what they're asking you? And can you describe with evidence your conclusion? So there's that. This video is way longer than I was hoping it would be. I should have said this at the beginning, but if you need to fast forward through things, do that. And in YouTube, it will let you increase the speed. So you can turn it on so that I talk twice as fast or 1.5 times as fast. For a lot of you, that will probably be very helpful. So I'll mention that at the beginning of the next video. But I'm sorry this one was a little bit longer.